Hey everyone, welcome to SETScast. I'm Rupal Nigam, your host for today's episode, and joining me as co-host today is Riley Schnee. Hi Riley, how are you doing?
I'm doing good. Thanks for asking, Rupal.
Awesome. So our guest for today is Swati Mohan, and she's the GNC operations lead for the Mars 2020 mission, and GNC is guidance, navigation, and control. Thanks for joining us today. How are you doing?
I'm doing great. Happy to be here.
Awesome. So to get started, can you tell us more about yourself, just including education, your past roles, what you're currently doing, and really anything else you want to share with us?
My name is Swati Mohan. I am currently working at NASA's Jet Propulsion Laboratory on the Mars 2020 Perseverance rover. I've been working on Perseverance for about the last 8 years. Before that, I worked on a few other missions, namely Cassini, probably know of. I worked on Cassini during the period between Saturn orbit insertion and probe release. I got my undergraduate at Cornell in Mechanical and Aerospace Engineering, and I got my master's and Ph.D. from MIT Aeroastro in the Space Systems Laboratory. While I was in graduate school, I worked on the Spheres project, which is actually a set of 3 satellites that are aboard the International Space Station. So that was my first glimpse into working in the space program with the astronauts on a scientific mission. So the past 8 years, I've been on Mars 2020 working in the guidance, navigation, control system. I worked all 3 phases of the mission, the cruise phase, entry, descent, and landing phase, and a little bit of it on surface. Mars 2020 right now is in a very crucial period. We launched in July of 2020, and our landing, our entry, descent, and landing is coming up here in just under 3 weeks on February 18th, 2021. So it's a very important milestone that we're kind of zooming ahead to.
Yeah, we really appreciate having you on during this what's probably a very hectic time. So thanks for being with us.
Sure.
So I guess from there, from NASA's website, sort of the main objective that's been made public is to seek signs of ancient life, collect samples in regolith, and see if we can return that to Earth. Can you tell us more about your involvement in the mission and sort of how you've been leading GNC?
So Mars 2020's main goal is to seek the signs of past life. Previous missions, such as Curiosity, Spirit, and Opportunity, have been focused on finding water on Mars. And Curiosity was able to determine that there was liquid water on Mars. Where liquid water exists on Earth, we know that life exists. So the main goal is to be able to use Perseverance to find the signs of past life. Now, this is important because Perseverance is actually the first leg of a campaign called Mars Sample Return. So Perseverance will actually be driving around and collecting samples that will one day be brought back to Earth. Once we have these samples on Earth, we can use the huge suite of technology and instruments and assessments that we have on Earth to actually dig into that question of whether or not Mars was habitable in the past and whether there are signs for life. Perseverance is going to Jezero Crater, which is a super interesting place because it actually is an ancient river delta. The images that we have of the Jezero Crater, you can actually see the river flowing into this basin. And why this is important for the scientists is because it actually preserves different materials that allows the scientists to determine the past habitability of Mars. Now, the same things at Jezero Crater that makes Mars interesting to scientists are the same things that the engineers worry about. There are all sorts of rocks and cliffs and craters, and while the geologists and scientists love these, we engineers get worried about landing something on top of these. If the rocks could tip you over, or you end up in a sand pit that you can't drive through. Perseverance actually has a brand new technology on it called terrain relative navigation. This technology is what allows Perseverance to go to Jezero Crater and actually land there safely. Jezero Crater was actually considered for past missions, including Curiosity, but was deemed way too hazardous to land safe. With terrain relative navigation, Perseverance can actually land with its eyes open. So as we come down on the parachute, Perseverance has a camera that will be looking at the ground and taking images. These images are then compared against a onboard digital map and correlated to figure out where Perseverance is with respect to the ground. Once Perseverance knows that, it can pick the safest, closest landing spot that it can reach, and it actually flies specifically to that spot. Terrain relative navigation allows Perseverance to find the small, safe spots in between all of these other hazards at Jezero Crater so that Perseverance can actually land in between all the interesting scientific features. In contrast, Curiosity actually had to land in the equivalent of a nice flat parking lot next to the really interesting, cool science part. So one of the key things that I've personally been working on the past 8 years is helping to implement and architect terrain relative navigation into Perseverance's entry, descent, and landing system.
That's super cool. The concept of terrain relative navigation sounds really interesting and complex. So that was cool to hear about. So you mentioned that you've been involved in these like 3 different phases of the Mars 2020 mission. So how has your role sort of like evolved in between those phases?
As I started on Mars 2020, the mission was actually in what we call Phase A. This was a purely paper design phase of the mission where we had to write down everything that we wanted the system to do and what level of performance. So I started on as the lead guidance and control systems engineer on Mars 2020, and that was my main role throughout the development portion of the mission. So at the beginning, when we were dealing with still the paper design, it involved writing a lot of requirements and architecting the system to be able to specify what we wanted it to do and how Perseverance was actually going to do that. In the middle of the mission life cycle in what we call Phase BC, this is when we're actually designing the system. So helping to write specifications on the hardware and making sure all the pieces that we have will do the job that we wanted it to do. When we moved into Phase CD, this was the getting your hands dirty part of the mission where we actually had the hardware in hand. We had versions of the software that we're now testing. So a lot of my time was actually spent in the test beds, actually running simulations and running testing on the hardware, using oscilloscopes and probes and various other sensors and actuators to actually make sure all the different pieces in the guidance and control subsystem did what they were supposed to do, and that we had a full understanding of how they behaved, not just under normal circumstances, but any off nominal or weird scenarios that we could throw at it too. This phase of the mission was really about doing a rigorous test program and fully understanding how the system works, both from a hardware and a software standpoint. We did a lot of testing with engineering mock-ups in clean room facilities. We did testing on the actual hardware that will go into space. We even did scenario type of testing where we took mock-ups of the hardware and flew them on helicopters out in the desert to make sure that they worked under realistic conditions where we couldn't control every variable, that they still performed like we expected them to do. And that really took us all the way to launch once the vehicle was all buttoned up into the launch vehicle. After that, my role kind of evolved into the operations lead. So now that we knew the system worked as we expected, we were ready to launch it. Once we launched it, we had to actually make sure that it got from Earth to Mars, all the way down to the surface of Mars successfully. So during cruise, we have a lot of activities that we do. We need to make sure that the whole spacecraft is oriented in the right way in order to maintain power on the solar arrays, in order to maintain communication between the antenna on Perseverance and Earth. We need to do course correction maneuvers to make sure it stays on the right course from Earth to Mars. All of this kind of folds into the different activities that we do during the 6-month cruise from Earth to Mars, including the checkouts of all of the hardware periodically through cruise to make sure they're still working properly, and will do what we expect them to do on the day of landing, which is February 18th, 2021.
That's really exciting. So I'm curious, because this project has been going on for so long, have there been any big milestones or, I guess, setbacks to any like interesting stories you have about hurdles that you faced along the way?
That's an interesting question. One of the aspects I can talk about there was the actual addition of terrain relative navigation into Mars 2020. At the very beginning, we weren't sure whether we needed it or not. The whole landing site selection process for 2020 is kind of, or for Mars mission in general, is a pretty long, thorough process. So at the very beginning, we can't just say, oh, there's one site we want to go to, we're just going to go to that. Each scientist, the general public, is welcome to come and pitch different regions on Mars and say what's cool about them, what's not. And then there's this voting process that happens amongst all the people in the community in order to basically upvote landing sites or downvote landing sites. And this process is kind of repeated 2 or 3 times over the course of a few years before we actually end up picking one. Through each of these milestones of these landing site selection workshops, the engineering team has to evaluate the probability of landing safely at each of these sites. So we go through different scenarios of what if Perseverance was going to land at this site, and what if Perseverance was going to land at this site. And both of those aspects, the scientific interest as well as the engineering capability to land at that spot, are weighed hand in hand before the final site selection is taking place. So as we were going through that process of figuring out where the scientists wanted to go, why they wanted to go there, what was interesting about it, whether we could actually get to it or not, we were going through this process of developing terrain relative navigation for Perseverance. But it wasn't until we decided that, yes, we were going to go to Jezero Crater, and because we were going to go there, we needed terrain relative navigation, that the two actually came together to formally include terrain relative navigation into Mars 2020 Perseverance rover. So until then, we actually had to kind of have two designs in play of if we did put it in or if we didn't put it in side by side for a few years before the final decision was made to include it.
That's super interesting. I had no idea how
Yeah.
like the whole process of the landing site being chosen. That was really cool to hear about. So I guess now with the Mars 2020 rover landing coming up in just a few weeks, how are you feeling about that?
I'm feeling pretty good. We had an exercise within the team where we had to list all of the things that we were worried about. And there are always things to worry about, but the comforting thing was that all the things on that list were so far-fetched, they're kind of like hand of God moments of something going wrong, that it gave a good feeling that we've really done our job and put Perseverance in the best shape that she can be, so that any credible scenario we feel like we're pretty ready for. So from here to landing day, we have our set of activities that we need to do on the vehicle to get her ready. There are a few more activities leading up into that week. What's interesting about Perseverance and Curiosity before is that they use a guided entry method into entry, descent, and landing. So what that means is that it's not just the position of where Perseverance is coming in from space, but what matters also is the knowledge Perseverance has of where she is, because she will use that knowledge to actually base how she flies through the atmosphere to land to the given target. So the final week, a lot of it is spent making sure we have the best knowledge on board Perseverance in order for her to be as accurate as she can be through entry, descent, and landing.
That's really cool. I'm curious, how, since you sort of got into GNC, you were involved in other projects before this. Is this something that you foresaw yourself doing back when you were in college?
The tale of how I got into guidance, navigation, and control is actually pretty interesting. When I was a sophomore in undergraduate, I had signed up to join a research project on campus, and it was a project to build a small CubeSat. So I had a interview with the faculty advisor for that team. And as part of this interview, he asked me a few questions, which at the time I found really weird and silly. He's like, okay, do you like things that stay still or do you like things that move? And I was like, well, I like things that move. That's more exciting. And then he's like, okay, do you like things that move slowly or things that move fast? I was like, I think I like things that move fast. That seems more exciting. So that's how he placed me in the attitude control subsystem for this CubeSat back when I was a freshman in undergraduate, or back when I was a sophomore in undergraduate. I actually hadn't taken any controls classes at all before I was placed into that group. So I was learning on the fly. And it really was based on those questions. There's so many different parts of a spacecraft. It's almost like the human body, right? There's the parts of the bones, which are like the mechanical system of keeping you upright. There's the thermal system, which is like the circulatory blood system that kind of keeps everything flowing and in sync and gets the temperature regulated across the whole body. There's the brain itself, which is the computer of all figuring out how to do all the instructions and all the commanding that needs to happen. The guidance, navigation, and control part is like the eyes and ears of the body. It senses where you are through the perception and through the ears, like figuring out how you're oriented. And it comes up with the commands of where do I need to go and how do I get there? And then sends the commands to your legs and your arms to get you to where you need to go. And that's how I kind of got into guidance, navigation, and control. And then I followed it from that undergraduate experience, which was super fun for me, into that same field for graduate school, and then even now into my job.
That's really awesome. I loved hearing your story of how you got to this role. So I guess after the landing, do you know how your role or your team's role is going to change?
So the way we've split up guidance, navigation, and control, we've kind of split it into two parts. One for the cruise EDL phase, and that's really associated with the getting from Earth to Mars and down to the surface. And then there's another phase once we're on the surface. And the reason there's a natural split there is because the way you do guidance, navigation, control for those different aspects is very different. In space, you're dealing with a lot of microgravity and F equals ma type of motions. You fire a thruster here, you go this way, even through entry, descent, and landing. On the surface, it's very different, actually. The fundamental difference is being that the rover can stop. And when the rover stops, when Perseverance stops, she's pretty safe where she is. In space, during cruise and entry, descent, and landing, there's no opportunity to stop. You're shot out of the rocket at the time of launch, and you got to keep moving until you go to entry, descent, and landing. There's no take backs, no wait, pause. So the way we do controls in those two different scenarios is very different. One is during cruising EL is constantly running and constantly tweaking the vehicle. The other one has the luxury of, I'm going to stop I'll stay here until I can figure it out, and then I'll continue driving. And that cadence is very different. So the team is kind of split into two. I chose not to transition to surface operations, so I have a counterpart who will be taking over for me on the surface operations side. My job ends actually on February 18th at like 3 p.m. for more or less. And then I get
So
to
do
go
you know
into
what
the
you'll be
field.
doing next after February 18th?
I am transitioning to a line manager position. I'll actually be a supervisor for the discipline of guidance, navigation, control system engineering. So it'll allow me to see not just Mars 2020 or the next mission like Mars sample return, but all the missions that our field contributes to, like Europa and Psyche, which are interesting missions that are also coming up.
Yeah, that'll be very exciting. You'll get to sort of broaden your perspective and see a lot more going on. Yeah,
Exactly.
that's
After being
awesome.
on Mars for the past 8 years, it'll be nice to see a different design, a different way of doing things.
That'll be awesome. All right. So since we're kind of cutting it close on time, what advice do you have for any of our listeners as far as, like, as we mentioned, maybe or recent graduates or college students? What would you advise to them for them to do while they're still in school?
The first advice I really have is to use the time when you're in school to really find your passion. Working in space exploration for me is really a passion, and that theme is kind of prevalent amongst my colleagues, and that passion fuels creativity, it fuels imagination, and it also gives the drive to be able to reach for the stars and to really stretch and to work hard and to achieve these great things and enjoy yourself while you're achieving them. Even if you do things, if you don't have the passion, you won't really appreciate the significance or importance of what it is that you're doing. And without being able to take the enjoyment of it, it kind of makes life bland. So I would first say use the time to find your passion and pursue that by working hard. There's no one path to get to NASA or to get to JPL or to get to working on these type of missions. It takes so many different disciplines, so many different fields in order to come together to achieve something technologically advanced like this, that there's really the opportunity to find your own path and to find that piece of you that inspires you and is your passion that you can then contribute to that area for the next mission or for the future.
Yeah, that was really inspiring. I definitely agree with a lot of what you said. And I think passion is something that comes up pretty often in our like space related conversations. So I think that's something that really unites people that are working in this field. So that wraps up the episode for today. Thank you for listening, and we hope to see you next time.